today's lesson, we'll be using Desmos to display data and find a linear regression equation. So today I'll show you how you'll use a set of data, and we use a set of data from example 3 in your booklet. And we'll create a scatter plot using Desmos to derive the line of best fit and find the linear regression equation. Now, Desmos, as I mentioned in a previous lesson, is a free online graphing calculator, and the interface looks like this. The interface looks like this here, but this is your screen when you do a search for Desmos. So we'll go to Google, get desmos.com. We'll end up this screen here, but then we want to go to the graphing calculator peer section, and it will look like this. So we'll look at question example 3. An example 3 question: if a rental company charges a flat fee of $150 and an additional $250 per kilometer driven to rent a moving van. The table here shows the cost of some rentals. So number of kilometers, the cost, 30 kilometers, $225. So this would be what we call a deposit fee, or initial fee. So there's no mileage, as they would say, no kilometers traveled, so you pay $150. Then after 30 kilometers, you pay $225, 58 kilometers, $295, and 90 kilometers, $375. So we'll use Desmos to create a scatter plot, but I would like to do a sketch on the graph paper before we go to Desmos. So this would be our x-axis, and this would be our y-axis. So we have number of kilometers here. And cost on your y-axis in dollars. Notice this goes from 0 to 90. So we start from a scale of 0. Now we need to go up to at least 90. So if we count the number of grid lines here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can meet every one of these at increment of 10. So we make this 30. These have to be of equal increments. So we have up to 100 kilometers here. Our cost goes from up to 375. So we have how many grids here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we make it 100, it'd be 1,000. So we can make each one of these, or 50. So if we make each one of these 50, each increment, so this is 150, 200, 250, 300, 350, 400, 450, 500. Notice you must have these of equal increments. They don't have to be the same increment as the x-axis. So you can have different increments, but they have to be the same as long as you cover the minimum of what's the data given here. So this is our given data, what we call the interpolation data. Next, we're going to plot the points on our graph. So at 0 kilometers, $150, which would be about here. 30 kilometers would give us $225, so 30 kilometers would be $225, which would be about here, halfway through. 58 kilometers, $295, so 58, $295 would be around point there. And finally, 90 kilometers at $375. So we put 90 at 375, 250 would be about here. So we take a ruler and construct a line of best fit. Try to go through as many points as possible. Remember that generally this is a sketch. this is, oops, made a mistake here. This is 90, would be here. Sorry about that. Up here. 93.75. So don't make a mistake I made. So this is 2.75, right? 3.75. So now we have our line. Let's fit. That's our line of best fit. Now, we haven't done any work yet on how to derive the equation based on this graph. So to determine the regression equation, we will be using Desmos. So Desmos will use this data, create a scatter plot as we have here, then have the line of best fit, and then we'll have the equation, the regression equation that models this situation here. And we will look at the cost of rental when you travel 65 kilometers. So we can do an estimate here. So when you travel 65 kilometers, according to our graph, our cost would be approximately $320. So we'll do an approximation here. This is our estimate based on our sketch. Next, if you were to drive 225 kilometers. Now, here, my scale is limited. So I need to extend my scale. So here, in this case, it'd be very difficult to do it unless I had rescaled my x-axis and the y-axis. So when we get to Desmos, we'll find if this matches up to our data, because our graph doesn't go beyond 100 kilometers here. So let's go to Desmos. I'll show you how to do this in Desmos. Now you could use a computer, or in my case, I'm using a tablet, an iPad. A little higher. Yeah. So this is our data. We're given data. So we'll use this set of data. So let me just adjust my iPad more. So I okay. There we go. So I can see my data on the side. First thing you want to do is to go to Google and type in Desmos, D-E-S. Okay, here. And now when the screen comes up, you can go straight to Desmos graphing calculator, but let's go to the first one. And the screen comes up and we hit start graphing. This interface will come up. Now we want to put our data into Desmos. So this is our table of values here. We have number of kilometers and cost. To create a table, we'll have to touch the plus sign, and it'll give you a menu. We have expression, note, table, folder, image. You would like to use a table. When the table comes up, you will then input your data on, this would be your x-axis here. This is your y values. So x-axis, y-axis, x value, y values. Now, a keypad will pop up. Now, if this keypad doesn't pop up, it will be at the bottom left-hand corner here. So you can just touch it and it will display. Now, use the keypad here to enter your data. So 0, enter. Now, you can go across x and y1, x2, y2, but I'll do the x column first and then the y column. 30. And you have to hit your enter button here. That should be not. It should be 58. Next will be 90. Next, I go to my y1, which is 150, 225, 295, and 375. Now I have put my data into my Desmos table, but I see no scatter plot. I see no points on. Now this is your graph. This is your x-axis here, and this is your y-axis. Now notice I touched and the keypad disappeared. If you want it back, come up here. But sometimes it's good for it not to be displayed. Now I don't see any of my scatter plot, my points. To see it, there's a plus sign just above the cell where it's flashing cursor. Hit that, and there, by hitting it, it will zoom in automatically. You can also use the plus sign here to zoom in or zoom out, or you can use your finger on it. If you're using a computer, you may have to use the cursor here, the plus or minus sign. Now, so this is my data. X equals 0, y is 150, x equals 30, y is 225, x equals 58. Notice almost like if I touch each point, it will show me the x and y coordinate points. That's one of the good features about Desmos. Now, we need to get our line of best fit. Now we have a scatter plot, we need a line of best fit. And this is where you'd have to go to cell 2, touch it, and get your keypad up. And this is something you may want to write down. Now, there is a handout on the blog that I've posted in the PDF that gives you the same step-by-step instruction. And it will give you also will have this formula of y1. Now, we're creating the equation y1, so we need to write y1. Now, automatically, that subscript is created for you. That's all I have to. Now, we have to put after y1, we need to put this tilde here. Now, let me show you what I did here. Now, this is what you have initially to get, I did not want to. Now, it tells you there are 4 elements here, and I'll tell you why there are 4 elements, and I'll show you once it's all up what that means. So you go to ABC, you need this tilde sign here. Now, if you're using your keypad on a computer, it's just below the escape button. So touch that. So you need that tilde sign there. Now we go to M and X. Now we deal with X1, so we go back to our number, put 1 there. There's our line appears, but we're not finished yet. We have to hit plus sign, go back here, and B. And there is our line of best fit. So now we've created a line. Now I'm going to display the line of best fit. We have our points. Now, the last part, where is our equation? Now, your equation is here. Y1 is equal to where the M is. Right? The M is 2.5. The X remains as a variable there, and B is 150. So your regression equation is Y is equal to 2.5 X plus 150. Okay, so we'll write that down. So I'll move this across here. So remember, we didn't have that. We couldn't derive it based on what we have here. So my regression equation is y is equal to, I'll just put it beside here. Very, very difficult to see, but it's y is equal. Now remove the tilde sign when you're writing the equation. Y is equal to 2.5 x, we don't need to write x1, plus replace the b with 150. And that is a regression equation. So now we've determined the regression equation. Just a little bit of explanation. And for those some of you already know it's about. Now, this 150 is called a y-intercept. So the y-intercept is a point on the y-axis where the graph crosses. And it's right here, where x is 0. So the y-intercept, the value of x is 0. So it tells me the graph crosses the y-axis at 150. And if you were to touch each one of the data we give us the x and y coordinates. Your m is referred to as the slope. Now, lesson 4, we will be looking at the equation of a straight line, which this is, but we'll look at how it's derived without a graphing calculator. So recap, step 1, we input our data in our x and y. By the way, if we touch here, it removes your data. So we have x and y coordinates. Then we input our equation. So y1 tilde, the tilde sign is critical, not an equal sign, tilde, m x1 plus b. Now this applies for every straight line. So every time you are asked to find a linear regression equation, a straight line, in other words, you will input this base formula, y1 tilde mx1 plus b. I'll do another question to show you how we repeat this formula for regression equation. Now we have a regression equation. We have it here, and that answers the first part of our question. Now, the second part of the question, use a regression equation to determine the cost of rental if the van was driven 65 kilometers. Now, from our graph, we could derive the approximate cost, 320. But we'll use Desmos to give us a more precise reading. So we need 65 kilometers, and this is what you will be doing. So I'll write this down here. So on Desmos, you will go to line 3 and input the x. Now this is your x value. So the x, so x is equal to 65, and what you're asked to find is your y value. So we put x is equal to 65. Once you put x equals 65, I'll show you what happens. So this is for line 3 here. We'll put here x. Now, if your keypad doesn't come up, get that. So you have x equals 65. Now a vertical line appears. This is the equation for a vertical line. Now the slope is undefined. Now this x is 65. Where it intersects the line, it will be the cost for rental. So 65 kilometers it will cost you $312.50. And so now, so we can conclude. So let's see what we have: $312.50. I have 320, pretty close. So the actual number is y is equal to $312. And 50 cents. So we're pretty close an estimate. Now we couldn't have done an estimate for the next one, 225 kilometers, because our scale is limited to 100 kilometers. So we'll use Desmos again, repeat the process. So we want 225 kilometers. Now I'll go to line 4, because I'm going to keep that one there to compare it. We'll repeat again, x equals 225 kilometers. 225. Now notice, I don't see any line as this one here. But if I were to zoom in or zoom out, there it is. Now you can use your 2 fingers, depending on what you're using, to get, now this is my line. For 225, it will cost you, this is your x value, $712.50. Now this slider here, this can tell you, if you now same whatever value you want. Let's say you want $200, 200 kilometers. Let's say we go 200 kilometers here. It will be $650. So this is a slider, but we want 225. So at 225, it will be $712.50. So when x is equal to 225 kilometers, y is equal to $712.50. So that's the cost for the rental if you were to drive 225 kilometers. So that's Desmos. It's a really powerful free graphing calculator. Now, if I don't want to see any of these lines, I can touch these here and just remove my equation. It's just don't display them. So that's how you use Desmos to create a scatter plot and derive the equation of a straight line and then interpret data. Now, one other question I would like to explore is the reverse. What happens if you want to just spend $500? How many kilometers would you then be able to travel? So in that case, I'll go to another line. And in this case, I'll have y now is equal to, because this is my y value here. If y is 500, what is x? So I'll go here, y equals 500. Now, if y is equal to 500, I can only travel 140 kilometers. So once you know your x, you can find y, or also if you know x, you can find y using this. And by the way, you can use a slider again. Let's go up, but it will only be limited to what value you have in your y coordinate. It's easier to just input the exact value into your Desmos, and that will give you your x and y coordinates. So this is my y. It's what I know, and I'm finding my x. The x refers to the number of kilometers you can drive with the van. Okay, so that answers question 3 using Desmos to create a scatter plot. Okay. We'll go on to another question, and this was example 2. Now, in example 2, we have temperature in Celsius scale. And in this case, we have 32 Fahrenheit, 2 equals 0 Celsius, 212 Fahrenheit, 100, 7725, 96.8, 36. So our X scale here will be degrees in Fahrenheit. So temperature, degrees Fahrenheit. And we're going up to 212. We can make this 50, 100, 150, 200, 250, 300. And going up here, we can make this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we can make the increment of 10. And this is temperature, degrees Celsius. We plot our points. So at 32 degrees Fahrenheit, which would be about here, 0. 212 is 100. Then we have 77 is 25. $96.836. Let me take a ruler and we'll have a line of best fit. Notice because we need our y-intercept in this case, or a line, we need to extend this line a little bit further, our y-axis to negative. So let's this is 0. Now this will be approximately negative 10, negative 15. So let's do a y-intercept. So here we have our data. And one of the question is, what's a degree Celsius if it's 10 degrees Fahrenheit? So 10 degrees Fahrenheit is about here. Okay, this is 32, this is 25, 10 is about. So if I were to go straight down from 10, it'll give me, according to my scale here, let's see here, put minus 11. So here. So this is about negative 11 degrees Celsius. Now that's a sketch, right? So when x is equal to 10, y is equal to, that's Fahrenheit, negative 11 degrees Celsius. Now, that's an estimate based on my scale. Will we use Desmos to find a more precise value? But here we can derive it algebraically, but that's for next lesson. We'll use Desmos to derive the regression equation. Okay. So here's your data. So I'll go back to Desmos, my iPad. Now, I will remove my previous set of data. Let me leave these here. Now, I do not remove your formula because this is a fixed formula for equation of a straight line. Let's say I don't have any of this here. I'm going to hit my plus sign here. I remove that. Now I need to input my table. So I'm going to get my plus sign there, hit table. Okay, so step one, once you're into Desmos, plus sign, table. Now, I want my table to be at the front here. So I'm going to put here plus. Now would I have to drag that? Yes, there we go. It's nice when it's at the top, but it doesn't matter. You can have it, you can drag. Now I'm going to input my X and Y coordinates. So I have 32 as my X, so 32, enter 212, center 7, 96.8. So I have my 4 and then my Y values. I need 0, 100, 25, and 36. Right away I have my data display here because I really zoomed in. But to get a better display, hit the plus sign, and now you see a better display. It doesn't matter, you can zoom in or zoom out, but the plus sign normally gives you a really better display. Now there's my scatter plot. I've entered it, which is very similar to what we have done with our sketch. Now I need my equation of the line here. So I go back here. No. Desmos, playing around. We have to redo this here. So this is B. Okay, and we have to replace my equation here. So Y 1 tilde M X 1 plus B. Now, my equation should show up, which is not in display here. See what happened. Let's try Y tilde, oh, Y1 plus B. And should have display here, some odd reason. y1, y equal mx plus b. Let's try that one more time. y1 tilde mx1 plus b. Now, I may have to come back to this in a minute, but our equation is not being displayed. Oh, now I see my error here. It should be in x1, and this should be y1. There we go. So there's my line of best fit. My equation now is y is equal to 0.55 or 56. Now this is my equation. So my regression equation. So I'll record that. So y is equal to 0.56x. I round it up. Here I'm rounding. Y is equal to, replace with a minus, 17.78. And that is the regression equation. The last question asks you, what is the temperature in Celsius when you're given the temperature of 10 degrees Fahrenheit? And in this case, you'll go to line 3, and you have x equals 10. So you have my x equal 10 line, because that's my x value. My x value is given, which is 10. And what is to be the y value? Negative 12.2. So if we go to our sketch here, which we had, we ended up with negative 11 degrees Celsius. So when x is equal to 10 degrees Fahrenheit, according to Desmos, y is equal to negative 11 or 12.2. So a 10 degrees Fahrenheit scale is negative 12.2 degrees Celsius. And you can find for any temperature. So go back to our Desmos. Let's say I want to find the degrees in Celsius when it's 250 degrees Fahrenheit. So my x is 250. Let's say it around here, 250. So when x is 250, get my keypad up, x equals 250, then y is 121.1. So Celsius, when it's 250 degrees Fahrenheit, it's 121.1 degrees Celsius. The reverse will be true if I know my degrees in Celsius, my y value. So say y, say it's equal to 100, that should give me 212 because I know that from my graph. So 212 degrees Fahrenheit is 100 degrees Celsius. And same thing, you can try that out. Let's say it's 150 degrees Celsius. What would that be? It will be 302 degrees Fahrenheit because your x value is your Fahrenheit. So today's lesson, we our goal was to goal today is to use Desmos to split data and find a linear regression equation. So we use a set of data from examples 2 and 3. We created a scatter plot. Then we derive our line of best fit and find a linear regression. And we interpreted certain questions. And all of that was done during Desmos. We initially did a sketch of our data, and then we go to Desmos to find the scatter plot and line of best fit. But more importantly, we needed the equation, the linear regression equation. And that's why we use Desmos. Now, the same method could be used in a graphing calculator, and I'll use a graphing calculator in the next session to complete the same process and derive the same linear regression.